Okay, here we go. We're going to look at multiples of various numbers. These are the multiples of 7, for instance. These are the multiples of 1, which is not surprising, gives all of the positive integers, sometimes called the natural numbers. Okay, we're looking for pattern. So multiples of 2 end in 0, 2, 4, 6, or 8. In other words, multiples of 2 end in an even numeral. On to multiples of 3. Here we're seeing that when you add all the digits, in this case there's only 2 in each case, say 7 and 8, you get a multiple of 3. And that works both ways. By adding all the digits, if you get a multiple of 3, then the original number is a multiple of 3. 8 and 1, 9. 9 and 3, 12. 6 and 6, 12. Always a multiple of 3. Okay, a bit more careful thinking now for the multiples of 4. If there's an odd tens, you're talking 0 is 2, 6, or 0. If there's an even, and you can see that here, 2, 6, or 0, 2, 6, or 0. So an odd tens requires any of the numbers 2, 6, 0, 2, or 6. Moving on then to a even 10, we're seeing a numeral or a digits numeral of 4 or 8. 5 ends in 0 or 5. 6 is even and is a multiple of 3. So 8 and 4 is 12 and it ends in even. 7 is a very cool one. So if you double the units and subtract from the tens, for instance 12 away from 5, I get minus 7. 18 away from 9, no, to 8, 16 away from 9, minus 7. And then you get things like 2 ones is 2, 2 away from 2 is 0. Now 0 is an integer multiple of 7. So when you subtract like that, you can get something like minus 14, minus 21, 0, 7, 14, as long as it's what we call an integer multiple of 7, not just a positive multiple of 7. 8, there's a pattern there, but we'll talk about it some other day. 9 is cool. The digits add to a multiple of 9. 5 and 4 is 9, 4 and 5 is 9, etc. Even here, 9 and 9 is 81. So any multiple of 9, the digits add to 9. It's like the 3's rule, except it's for 9. 11, multiples of 11 have all the odd integers added up, subtract all the even position integers, and you do that, you get a multiple of 11. I don't want to talk about that some other time. They actually all have patterns, believe it or not. Every single set of multiples have a pattern. Just some of them can seem a bit complicated. Now I'm going to extend the box so we look at 2 of them for just studying lowest common multiples.